Preparing for an Angular developer interview questions and answers interview? You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is the difference between a component and a directive in Angular? A component is a directive with a template. I use components to create reusable UI blocks like product cards, dashboards, or forms. Directives are for changing behavior or structure of existing DOM elements. For example, ngIf and ngFor are structural directives, while ngClass changes styling. If I need UI plus logic, I create a component. If I only need to enhance an element, I create a directive. While answering, focus on component templates, directive behavior extension, structural versus attribute directives, reusable UI, DOM manipulation boundaries, and when you would create each in a real application. Question 2. Explain Angular's change detection mechanism. How can you optimize it? Angular change detection keeps the view synchronized with component state. By default, Angular checks the component tree after async events, like clicks, timers, or HTTP responses. For optimization, I use change detection strategy.onPush, so Angular checks a component only when inputs change, events fire, or observables emit through async pipe. I also avoid heavy template functions, use track by-in loops, and prefer immutable updates. In newer Angular, signals provide more targeted reactivity. Make sure to cover Zone.js, component tree checks, default versus on-push strategy, immutable data, async pipe, track by, signals, and avoiding unnecessary template method calls. Question 3. What are Angular lifecycle hooks, and which ones have you commonly used? Lifecycle hooks let me run code at specific stages of a component's life. I commonly use NgOnInit for initialization such as loading data, NgOnChanges to react when input values change, and ngAfterViewInit when I need access to view child elements. NgOnDestroy is critical for cleanup, especially unsubscribing from manual subscriptions or removing event listeners. The key is not putting heavy logic in constructors. Constructors should only handle dependency injection. In your answer, talk about initialization, input changes, view and content initialization, cleanup, NgOnInit, NgOnChanges, ngAfterViewInit, NgOnDestroy, and common mistakes around subscriptions. Question 4. How does dependency injection work in Angular? Dependency injection is Angular's way of giving a class the dependencies it needs instead of creating them manually. I usually create services and provide them with provided-in root, which makes them singleton application-wide. Angular's injector resolves the dependency and passes it through the constructor or inject function. Because injectors are hierarchical, a component can also override a service locally. This makes code easier to test, mock, and maintain. Be sure to mention providers, injectors, service lifetimes, provided-in root, hierarchical injection, constructor injection, testing benefits, and how DI reduces tight coupling between classes. Question 5. What is the difference between template-driven forms and reactive forms? Template-driven forms are simpler and rely heavily on directives like NgModule in the template. I use them for small forms with basic validation. Reactive forms are model-driven. I define form control, form group, and validators in TypeScript. They are easier to test, scale, and handle dynamically, especially for enterprise forms with conditional fields. In interviews, I usually recommend reactive forms for complex applications because the form state is explicit and predictable. While answering, compare control ownership, scalability, validation style, testability, dynamic forms, form control, form group, NgModule, and when each approach fits production scenarios. Question 6. How do observables differ from promises in Angular? A promise handles one future value and starts immediately. An observable is lazy, can emit multiple values over time, and can be canceled by unsubscribing. Angular uses observables heavily because UI events, route parameters, WebSocket streams, and HTTP requests fit reactive patterns. With RxJS operators like map, switchMap, debounce time, and catch error, I can transform and control streams cleanly. For templates, I prefer async pipe because it subscribes and unsubscribes automatically. Make sure to cover lazy execution, multiple emissions, cancellation, RxJS operators, async pipe, HTTP behavior, error handling, and why Angular heavily uses observables. Question 7. When would you use switchMap, mergeMap, concatMap, and exhaustMap in RxJS? These operators handle inner observables differently. I use switchMap for search boxes because it cancels old API calls when a new value arrives. mergeMap runs requests concurrently, useful when order does not matter. concatMap queues requests and preserves order, good for sequential saves. exhaustMap ignores new triggers while one request is active, useful for preventing double submit. The choice matters because the wrong operator can create stale data or duplicate writes. In your answer, explain flattening operators, cancellation, concurrency, ordering, ignoring repeated triggers, API request examples, and how choosing the wrong operator causes race conditions. Question 8. How would you implement lazy loading in an Angular application? Lazy loading means loading feature code only when the user navigates to that feature. In older Angular apps, I use load children to load a feature module. In modern Angular, I can lazy load standalone routes or components directly. This reduces the initial JavaScript bundle and improves startup time. I typically organize large domains like admin, reports, or checkout as lazy routes. For important routes, I may add a preloading strategy after the first render. Be sure to mention route-level code splitting, load children, standalone component loading, feature boundaries, preloading strategies, bundle size impact, and user-perceived performance. Question 9. What are route guards in Angular, and where would you use them? Route guards control whether navigation is allowed. I use canActivate for authentication and authorization, canDeactivate to warn users about unsaved form changes, and canMatch to control whether a lazy route should match. A guard can return true, false, a URL tree, promise, or observable. For example, if a user is not logged in, I return a URL tree to the login page. Guards improve UX, but real security must still be enforced on the backend. While answering, cover canActivate, canDeactivate, canMatch, authentication, authorization, unsaved changes, lazy route protection, returning URL tree, observables, and security limitations. Question 10. How do HTTP interceptors work in Angular? HTTP interceptors sit between Angular's HTTP client and the backend. I use them for cross-cutting concerns like attaching JWT tokens, adding correlation IDs, handling 401 errors, retrying transient failures, or toggling global loaders. Since HTTP request is immutable, I clone it before modifying headers. Interceptors can also inspect responses and transform errors centrally. The order matters, especially when combining auth, logging, and error interceptors, so I keep each interceptor focused. Make sure to cover request and response interception, auth tokens, headers, error handling, retry logic, loading indicators, immutability of requests, and interceptor ordering. Question 11. What is the purpose of the async pipe in Angular? The async pipe subscribes to an observable or promise and renders the latest emitted value in the template. Its biggest advantage is lifecycle management. Angular automatically unsubscribes when the component is destroyed. That reduces memory leaks and boilerplate. It also works very well with on-push change detection because it marks the component for checking when a new value arrives. I prefer async pipe for UI-bound streams instead of manually subscribing in TypeScript. In your answer, mention automatic subscription management, change detection triggering, observable and promise binding, avoiding memory leaks, cleaner templates, and interaction with on-push components. Question 12. How do you manage state in a large Angular application? I start by separating state types. Local UI state stays inside components. Shared feature state can live in services using behavior subject, signals, or a small store pattern. For large apps with complex workflows, I consider NGRX because actions, reducers, effects, and selectors make changes traceable and testable. I do not add global state management by default. It has overhead. The goal is predictable data flow without turning simple screens into architecture projects. Be sure to discuss local component state, shared services, RxJS stores, NGRX or similar libraries, signals, server cache separation, complexity trade-offs, and debugging needs. Question 13. What are standalone components, and how are they different from NgModule-based architecture? Standalone components allow Angular building blocks to declare their own dependencies directly using imports, without being declared in an Ng module. This reduces boilerplate and makes components easier to reason about and lazy load. Modern Angular apps can bootstrap with Bootstrap application instead of app module. Existing NgModule-based code still works, so migration can be incremental. I like standalone architecture because feature boundaries become more explicit and route-level composition becomes simpler. While answering, cover standalone true, direct imports, reduced module boilerplate, bootstrapping, route configuration, migration strategy, feature organization, and compatibility with existing modules. Question 14. How would you improve performance in a slow Angular page with a large list? I first profile instead of guessing. For a large list, I add track by, so Angular reuses DOM nodes instead of recreating them. If the list is huge, I use pagination or CDK virtual scrolling to render only visible rows. I switch heavy components to onPush, avoid calling methods from templates, debounce search filters, and move expensive transformations into memoized selectors or pure pipes. Often the biggest win is reducing DOM size, not micro-optimizing TypeScript. Make sure to cover profiling first. Track by, virtual scrolling, pagination, onPush, pure pipes, avoiding template functions, debounced filtering, backend pagination, and DOM size reduction. Question 15. What is the difference between pure and impure pipes? A pure pipe runs only when Angular detects a pure change, such as a new primitive value or object reference. That makes it efficient for formatting dates, currencies, or labels. An impure pipe runs on every change detection cycle, so it can become expensive quickly. I avoid impure pipes for filtering or sorting large arrays in templates. Instead, I compute data in the component, use observables or selectors, and update references immutably. In your answer, talk about when pipes execute, reference changes, mutation pitfalls, performance impact, examples like date formatting versus filtering arrays, and safer alternatives. Question 16. How do you handle memory leaks in Angular applications? Memory leaks usually come from subscriptions, timers, DOM listeners, or cached references that outlive a component. My first preference is async pipe because it handles unsubscribe automatically. For manual subscriptions, I use take until destroyed or a cleanup pattern in ng-on-destroy. I also clear intervals, remove custom listeners, and review share replay usage because it can retain values unexpectedly. In production debugging, I use browser memory profiles to compare heap snapshots after repeated navigation. Be sure to mention manual subscriptions, async pipe, take until destroyed, component cleanup, event listeners, timers, share replay pitfalls, DevTools profiling, and avoiding long-lived references. Question 17. What are Angular signals and how do they compare with RxJS? Signals are Angular's newer reactive primitive for holding and deriving state. A signal stores a value, computed derives values from other signals, and effect runs side effects when dependencies change. Signals are synchronous and great for local component or UI state with fine-grained updates. RxJS is still stronger for asynchronous streams like HTTP, WebSockets, cancellation, and complex event composition. I see them as complementary, signals for state, RxJS for streams. While answering, cover signal, computed, effect, synchronous state, fine-grained reactivity, template updates, RxJS for async streams, interoperability, and practical usage boundaries. Question 18. How would you secure an Angular application against common front-end vulnerabilities? Angular helps prevent XSS by escaping template expressions and sanitizing risky bindings. but I still avoid bypass security trust HTML unless absolutely necessary. I validate and authorize on the back end because front-end checks can be bypassed. For authentication, I avoid exposing sensitive data in local storage when possible, and consider secure HTTP-only cookies depending on the architecture. I also use HTTPS, keep dependencies updated, apply CSP where feasible, and remember that route guards are UX controls, not security boundaries. Make sure to cover XSS protection, sanitization, avoiding unsafe inner HTML, off-token storage, CSRF awareness, route guard limitations, HTTPS, dependency updates, and backend enforcement. Question 19. How do you test Angular components and services? For services, I write focused unit tests and mock dependencies through testbed or simple stubs. For HTTP services, HTTP testing controller lets me assert requests and flush mock responses. For components, I test inputs, outputs, template behavior, validation states, and interaction with mocked services. I avoid testing Angular itself. I test my logic and integration points. Critical user journeys like login or checkout belong in end-to-end tests using tools such as Cypress or Playwright. In your answer, discuss unit tests, testbed, mocking dependencies, HTTP testing controller, component interaction tests, async testing, shallow testing, and what belongs in end-to-end tests. Question 20. How would you explain Angular server-side rendering and hydration? Server-side rendering generates the initial HTML on the server instead of waiting for the browser to download and run all JavaScript. This helps SEO and improves perceived load time, especially for content-heavy pages. Hydration then attaches Angular behavior to the existing DOM instead of rebuilding it from scratch. I watch for browser-only APIs like window or local storage during SSR and use guards. SSR adds operational complexity, so I use it where SEO or first paint matters. Be sure to mention SSR rendering HTML on the server, SEO, faster first contentful paint, hydration, reusing DOM, browser-only API issues, transfer state, and trade-offs. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.